Everyone, have you ever wondered what Python is and why so many developers, data scientists, and even kids love using it? Well, today I'm here to introduce you to Python, a programming language that is powerful yet easy to learn. Python is a beginner-friendly programming language. It's versatile, meaning it's used for everything from web development to artificial intelligence. The best part? Its syntax is so simple and reads almost like plain English, which makes it perfect for absolute beginners. See how much simpler Python is? With just one line of code, we can make the computer say hello world. Python can do a lot. You can use it to build websites, analyze data, power artificial intelligence, or automate boring tasks. So whether you want to become a developer or just solve daily problems, Python is the perfect starting point. Now let's write some Python together. Don't worry if this is your first time, it's going to be fun. The print command prints whatever is inside the quotes. In this example, we're storing information in variables and then using them in a sentence. And with the last example, with just 3 lines, you can do math. Hence, if you're excited to try Python, you don't even need to install anything. Just visit an online Python editor like Google Colab and start coding right away. In this video, we scratch the surface of Python. In future videos, we'll explore projects, tips, and real-life applications. Today, we're diving into Python, starting with the basic syntax, comments, indentation, and the fundamental data types, integers, floats, strings, and booleans. Let's code as we go along to understand things better. You can open your Python editor, Jupyter Notebook, or Google Colab, and let's get started. Python is known for its simplicity. It uses clean and readable syntax. We'll begin with the most famous program, printing hello world. Here, print is a function that outputs text. The message is enclosed in double quotes. It's that simple. Now, let's learn about comments. Comments are ignored by Python but help explain the code. Single line comments use the hash symbol. For multi-line comments, we use triple quotes. Let's see an example. Python uses indentation instead of curly braces. Every code block must be indented correctly, usually by 4 spaces. Notice how indentation groups the code inside the if block. If we miss the indentation, Python throws an error. Now let's move to variables and data types. Variables store data and Python can automatically infer the data type. We'll start with integers. An integer is a whole number. We'll assign some values to variables and print them. Python allows us to perform arithmetic operations on integers like addition and division. Floats are numbers with decimal points. They're useful for precise calculations. Like integers, you can perform operations on floats too. Strings are sequence of characters enclosed in quotes. So let's try it out. You can also combine strings using the plus operator. Strings can be sliced and indexed. Indexing starts at 0. And we also have a provision of negative indexing in Python. Booleans represent true or false. They are often used in conditions. Booleans also result from comparisons. We'll see by comparing some numbers here. Great job! You've now learned Python basic syntax, comments, indentation, and structure, and how variables work with different primitive data types, integer, float, strings, and boolean. Here's a fun challenge. Write a Python program that asks for your name and age and then calculates the year you'll turn 100. You can pause the video, complete the solution, and then replay the video to see my solution here. So at first, you ask your user for your name and the age. You'll mention the current year in this current year variable, and then you'll apply this formula To calculate the year, you'll turn 100 and print it. So congratulations, you've made a great start in Python. Practice these concepts, play with variables and try out new operations. Next, we'll explore the data structure like lists, tuples and dictionaries. We're diving into complex data types in Python: list, tuples, sets and dictionaries. If you're a beginner or brushing up on Python, you're in the right place. These data types are super powerful and widely used in Python to handle collections of data. Plus, I'll show you some hands-on examples that you can run alongside me. So grab your Python environment, whether it's Google Colab or Jupyter Notebook, and let's get started. First of all, we'll start with lists. A list is an ordered, changeable collection that can hold multiple data types. Lists are defined using square brackets. To access an element of list, we use indexing. Remember, Python starts counting from 0. Also, there is a provision of negative indexing in Python. List also supports several operations like adding, removing, and sorting elements. To add elements to a list, we use the append function. To remove element from the list, we use remove function. And to sort the elements, we use sort function. Next, we have tuples. A tuple is very similar to a list, but it's immutable, which means once created, you cannot change its element. Tuples are defined using small parentheses. We can also index the tuples like we used indexing in list. Now let's try changing an element in a tuple. We'll see what happens. As you can see, tuples are read-only data types and they do not support item assignment. Moving on to sets. Sets are unordered collection that do not allow duplicate values. They're defined using curly braces. We can add and remove elements in our set using add and remove function. Finally, we have dictionary. A dictionary is a collection of key value pairs. Each key is unique and maps to a specific value. Dictionaries are defined using curly braces with key and value separated by a colon. Here we create a student dictionary with keys name, age and major. And if we want to access any value inside our dictionary, we use the key. We can also modify the values in our dictionary using the key. Now it's your turn. Here's a fun challenge for you. Create a dictionary to store details about your favorite movie. Add the following keys: title, which contains the name of the movie; year, the release year of the movie; rating, your personal rating for the movie out of 10. Print out the dictionary and access each value individually using its key. Pause the video, try it yourself, and then come back to see the solution. Here we can see the solution. I have created a favorite movie dictionary with title, year and rating, and then I printed them each using their respective keys. And that's for it today's video. We covered list, tuples, sets and dictionaries with examples and operations. Let me know in the comments which data type you found the most interesting. In this video, we'll be diving into the basic operations in Python: arithmetic, comparison, logical and assignment operations. Whether you're a beginner or brushing up on Python basics, this video will give you the practical knowledge you need to use these operations effectively. Let's start mastering Python operations. In Python, operations are a fundamental part of writing functional code. We'll explore 4 types of basic operations: arithmetic, comparison, logical and assignment. First, let's go over arithmetic operation. They're used to perform mathematical calculations like addition, subtraction, multiplication, division, and more. Here, We're using basic arithmetic commands like addition, subtraction, multiplication, division, floor division, modulus, and exponential. We'll break it down. Plus adds two numbers here. Minus subtracts the second number from the first. Multiplication sign multiplies the two numbers. Divide sign divides the first number by the second, giving a floating point result. Double division performs floor division, which returns the largest integer less than or equal to the quotient. Percentage gives the remainder when the first number is divided by the second, which is basically the modulus operation. And double multiplication sign raises the first number to the power of the second. Now we'll look at comparison operations. These are used to compare two values and return a Boolean result, true or false. Here are the comparison operations. Double equal to checks if two values are equal. Not equals to checks if two values are not equal. Greater than checks if the first value is greater than the second. Less than checks if the first value is smaller than the second. Greater than or equal to checks if the first value is greater than or equal to the second value, and less than or equal to checks if the first value is less than or equal to the second value. Now we'll explore some logical operations. Logical operators are used to combine multiple conditional statements and return Boolean result. And returns true if both operands are true, otherwise it returns false. Or returns true if at least one operand is true, otherwise it returns false, and not reverses the logic state of its operand. Finally, now we'll talk about assignment operations. These are used to assign values to variables, and we can even perform operations while assigning a value. Plus equals to adds a value to a variable and assigns the result back to it. Minus equals to subtracts a value from a variable. Multiplication equal to multiplies a variable by a value. Division equal to divides a variable by a result. Double division equal to performs floor division and assigns the results. Percentage equals to calculates the remainder and assigns it. And power equals to raises the variable to the power of the given number. Now that we've gone through the basic operations, it's time for a hands-on exercise to reinforce what you've learned. I'll give you a task to complete, and you can pause the video to try it yourself. So the task is create a Python script that first of all assigns values to two variables x and y, perform all types of operations on x and y, and print the result of each operation along with the caption of what operation is being performed. Great job! Now that you've completed the exercise, you should be comfortable with basic operations in Python. Remember, practice is key to mastering these concepts. In today's video, we'll explore type conversion and casting in Python. We'll learn how to convert data types, why it's important, and practice with hands-on examples. Whether you're a beginner or revisiting Python concepts, this video will help you master type conversion and casting in no time. So let's get started. Before diving into examples, we'll understand what type conversion and casting mean. So type conversion is a process of converting one data type into another. And casting means when you manually convert a data type using a specific Python functions like int, float, str, etc. It's called casting. In Python, we have two types of conversion, implicit conversion and explicit conversion. We'll first talk about implicit type conversion. Python sometimes converts data types automatically when it's safe to do so. This is called implicit type conversion. We'll see this example here. Here, integer value is an int and float value is a float. Python automatically converts the int to a float during the addition operation because it's safe. The result is a float. So Python takes care of implicit conversion when no data is lost, but sometimes we need to manually convert data types. That's where explicit conversion comes in. Now let's talk about explicit type conversion or casting, where we manually change one data type to another using functions like int, float, str, and more. Int float value removes the decimal part and keeps only the integer. Int string value converts a numerical string into an integer. Similarly, float integer value adds a decimal point to the integer, and float string value converts a numeric string to a float. Similarly, str function converts any data type like integer or float into a string. Sometimes we encounter errors when performing type conversion. We'll see a common mistake. Here we see a string hello. So if a string contains non-numeric characters, it cannot be converted into an integer or float. Here the try except block handles the error gracefully, which is also called exception handling. We'll cover exception handling in the later video. Now it's time for a hands-on exercise. Here's the task. Ask the user to input two numbers as strings, convert those two inputs into integers, perform arithmetic operations, addition, subtraction, multiplication, and division, and show the results. Pause the video, try this on your own, and let me know in the comment how it went. If you face any issues, I'll be happy to help. So, to summarize, today we learned about type conversions in Python, including implicit conversions, which is done automatically by Python, and explicit conversions using functions like int, float, and str. Please make sure to practice these concepts and try out the exercise. In this video, we're going to tackle one of the most essential concepts in programming, conditional statements. We'll break down if, else, and elif statements, explore nested conditions, and practice with a fun hands-on exercise at the end. Whether you're a beginner or revisiting Python basics, this video will help you write smarter and decision-driven code. So let's get started. Imagine you're at a traffic light. If the light is green, you go. If it's red, you stop. And if it's yellow, you slow down. You've just made decisions based on these conditions. In Python, conditional statements helps us make such decisions in our code. These include if, else, and elif. If checks a condition and runs code if it is true. Else runs code if the if condition is false. And elif is used when we have multiple conditions to check. We'll also learn about nested conditions, where we use conditions inside other conditions. The if statement checks whether a condition is true. If it is, the block of code inside the if statement runs. We'll see an example. Here, the condition is greater than or equal to 18 is checked. If it's true, the code inside the if block runs. If it's false, nothing happens. So, as we see in the output, the if condition is satisfied. Here the condition is true, so Python prints the message. But what if the condition is false? That's where the else statement comes in. The else statement runs a block of code when the if condition is false. We'll see an example. If the condition is greater than or equal to 18 false, the code inside the else block runs. This makes it easy to handle two outcomes, one for true and one for false. But what if we have more than two conditions? For example, grading a student based on the score. That's where the elif statement comes in. The if checks if the score is 90 or above. If not, the elif statement checks other conditions in order. Finally, if none of the conditions are true, the else block runs. This allows us to handle multiple conditions one after the other. Sometimes we need to check conditions inside other conditions. This is called nesting. We'll see an example. Here, the first if checks if the age is greater than or equal to 18. Inside this if, there's another condition to check if has underscore id is true. If the age is less than 18, the outer else runs. These kind of nested conditions are powerful when we need to make decisions step by step. Just be careful not to overuse them, as they can make your code harder to read. Alright, it's time for a hands-on exercise. Here's your challenge. Ask the user to input their score, a number between 0 and 100. Use if, elif, and else to grade them based on this scale. If the score is 90 and above, give them an A. If it's between 80 to 89, give them a B. If it's between 70 to 79, give them a C. If it's between 60 to 69, give them a D. And if the score is below 60, give them a F. Add a nested condition to check if the score is exactly 100 and print perfect score. Pause the video, try this challenge and share your answers in the comments. I'll check them and provide the feedback if needed. So in conclusion, today we covered conditional statements in Python. We used if to check a condition, we used else to handle when the condition is false, we used elif for multiple conditions, and we used nested conditions to put conditions inside other conditions. Please make sure to practice the exercise and try creating your own examples to strengthen your understanding. In today's video, we're going to dive into one of the most powerful tools in programming, loops. Loops allows us to repeat actions and process data efficiently. We'll cover the for loop, the while loop, and most important loop control parameters like break and continue. By the end, you'll not only understand how loop work, but also get a chance to practice with a fun hands-on exercise. So let's get started. Imagine you need to print numbers from 1 to 100. You can write 100 lines of code, but that's inefficient. Loops let you repeat actions without writing repetitive code. For loop is used when you know the number of iterations in advance. While loop is used when you don't know the number of iterations but you have a condition to stop. And loop control statements are used to control the flow of the loop. Break is used to stop early and continue is used to skip an iteration. We'll start with for loop. The for loop is used to iterate over a sequence like a list, string, or a range of numbers. We'll see a basic example here. The range 1 to 6 generates a number from 1 to 5. The variable I takes each value from the range one at a time, and the print function prints I on each iteration. Here, the loop runs 5 times and I takes on each value from 1 to 5. You can use the for loop with other sequences like list or strings too, as shown in the example below. Now we move to while loop. Unlike the for loop, the while loop keeps running until a condition becomes false. We'll see an example here. Here, the loop checks if count is less than or equal to 5. If true, the code inside the loop runs. After each iteration, count increases by 1. While count becomes 6, the condition is false and the loop stops. But be careful with while loops. If you forget to update the condition, this could go into infinity or the loop could run forever. Now, moving on to the break statement. The break statement is used to exit the loop early. Let's say we want to stop a loop when a certain condition is met. So the loop prints number from 1 to 9, but when I equals to 5, the break statement exits the loop early. The continue statement. The continue statement is used to skip the current iteration and move to the next one. We'll see an example again. So here when I equals to 3, the continue statement skips the rest of the code in the loop for that iteration. The loop continues with the next value of I. Use break when you want to stop the loop and continue when you want to skip to the next iteration. Alright, it's time to test your knowledge now. Here's a challenge for you. Use a for loop to print numbers from 1 to 20. Use the continue statement to skip multiples of 3. And use the break statement to stop the loop when the number reaches 15. Pause the video, give it a try and share your output in the comments. I'll be checking them and providing feedback. So, in conclusion, today we explored loops in Python. The for loop for iterating over sequences, the while loop for repeating actions based on a condition, the break statement to exit a loop early, and the continue statement to skip iterations. Make sure to practice this hands-on exercise and experiment with these concepts to build confidence. Have you ever wondered how Python functions actually work? How do we pass parameters and get written values? And what's up with global and local variables? If you're a beginner or someone brushing up on Python, this video is for you. By the end of this video, you'll not only understand functions, but also how to avoid common mistakes while handling variables. So let's dive right into it. We'll start with the basics. In Python, a function is a reusable block of code that performs a specific task. It saves you time, makes your code cleaner, and avoid repetition. Here, def is the keyword to define a function. Greet is the function name, and print is what this function does. Simple, right? Now let's level up with parameters. A function becomes more powerful when you can pass information into it. These inputs are called parameters or arguments. Here, name is the parameter of the function greet user. When we call the function, we provide an argument like Alice or Bob, which gets passed to the parameter. Think of it like passing ingredients into a recipe. Sometimes you want your function to give something back, a result, a calculation, or a processed value. That's where the return value comes in. The return keyword sends the result back to wherever the function was called. Here, 5 and 3 are added and the sum is returned to the variable result. Without return, the function would just print it and not store the value. Here's where things get interesting. Variable scope. A variable scope determines whether it can be accessed in your program. These are of two types, local and global. Local variables are created inside a function and can only be used there. Here, result is a local variable. It's created inside the function and it goes away once the function ends. If you try to use the result outside the function, you'll get an error. Global variables, on the other hand, are defined outside the function and can be used anywhere. Here, global result is defined outside the function and is accessible anywhere in the program. The global keyword allows the function to modify it. But wait, global variables can make your code messy and hard to debug. Always prefer using local variables unless absolutely needed. Alright, we'll quickly recap what we learned today. Functions are a reusable block of code. Parameters allows you to pass inputs to a function. The return keyword lets your function send result back. Variables have scope. Local variable exists inside functions while global variable can be accessed anywhere. But please use them wisely. Now with this knowledge, you can write cleaner, reusable and more efficient Python code. Now, as always, it's your turn. Here's a quick challenge for you. Write a function that calculates the area of a rectangle. Pass the length and width as parameter and return the area. Drop your solution in the comments below. Today, we're diving into a super powerful concept in Python, args and kwargs. You've probably seen these in Python code, but what do they mean? And why are they so useful? By the end of this video, you'll know what args and kwargs are, how to use them with real-world examples, and why they make Python functions so flexible. So grab your coffee and let's dive right in. Before jumping into args and kwargs, let's quickly recap function arguments. In Python, a function can take positional arguments based in order, and keyword arguments passed with a name. But what happens when you don't know how many arguments your function will take? That's where args and kwargs come in. So let's explore them. Args allows you to pass a variable number of positional arguments to a function. Think of args as a way to bundle multiple arguments into a tuple. In the example, args collects all the arguments into a tuple so we can iterate or perform operations like sum here. In another example, team lead is a regular argument and team members bundles the rest of the arguments into a tuple. We can also use arg in mathematical operations. So with args, you can pass any number of arguments without changing the function definition. Now let's move on to kwargs. Kwargs stands for keyword arguments. It allows you to pass a variable number of named arguments to a function. These arguments are bundled into a dictionary. Here, in this example, kwargs gathers all the keyword argument into a dictionary and you can access them using dot items. In this second example, where we have mixed regular arguments and kwargs, the order ID is a regular argument while items takes any additional named arguments. We can also use default value with kwargs. In this example, we use the get method to set a value or to set a default value if the key doesn't exist. What we can also do is combine args and kwargs in the same function. In this example, args handles the positional argument and kwargs manages the keyword arguments. Alright, we've covered a lot today. You learned what args and kwargs are, how to use them in various scenarios, and how they make your functions incredibly flexible. Now, here's your challenge. Write a function that accepts any number of positional and keyword arguments. Print the sum of all positional arguments and display all the keyword arguments. Share your solution in the comment below. In today's video, we're diving into one of the coolest features of Python, that is nested functions. But what exactly are they? How are they different from functions in other programming languages? And why should we care about them? We're going to explore these questions step by step with plenty of examples, so stick around. In Python, a nested function is simply a function defined inside another function. This means that a function can be used as a building block for other functions. This behavior is not unique to Python, but Python allows such functions in a very clean, intuitive way, and we're going to take a look at some real-world use cases. So imagine we have a function that performs a complex task, but you only need a small piece of it in the middle of that task. Instead of cluttering your code with unnecessary functions, you can define that smaller piece right inside your main function. We'll take a look at a simple example. Here's how a basic nested function looks in Python. We have our main function, and inside it we define another function. In this example, we have outer function, which contains another function called the inner function. The cool thing here is that the inner function is only available within the outer function. When we run the code, and when we call for the outer function, the inner function gets called first, and then the outer function prints its statement. So let's break it down. When you run this, you get the following output. Now, you might be thinking, hey, these are not Python exclusive features, and you're right, other programming languages also support such functions. But what's unique about Python is how it handles scope and how easily nested functions are integrated into the language. In many languages, such functions can often feel like a hack or an afterthought, but in Python, they're deeply integrated into the language's structure, making it possible to achieve elegant solutions to real-world problems. We'll see how this plays into practice. One of the most powerful features of such function in Python is the concept of closures. A closure happens when a nested function remembers and has access to variables in its containing function, even after that containing function has finished executing. Here's what's going on in this example. We define outer function x, which takes the parameter x. Inside outer function, there's an inner function y that takes another parameter y and then adds it to x. Now here's the magic. When we call outer function 5, it returns inner function, and inner function remembers the value of x even though outer function has finished executing. When we call add 5 and then pass the parameter 10 to it, it adds 5 from the outer function and then 10 from the inner function, and the output is 15. Notice how the inner function is able to access x, even though it was defined in our outer scope. This is a prime example of how closures work in Python, and it's something that makes Python's nested functions incredibly powerful and flexible. Now let's talk about the real-world use case where such functions shine. Encapsulation. Sometimes you don't want certain functionality to be accessible outside of a function because it's not needed. This is where such functions help keep things tidy and avoid polluting the global namespace. Say we are working with an application that involves processing user input and calculating the results. We don't need to expose every helper function to the outside world, only the ones that are essential. Here's an example. In this code, we have a process input function that performs two tasks. It validates the input and processes it. The validate input function is nested inside process input and is not available outside. If the input is invalid, we return an error message. If it's valid, we double the input and return it. When you call the process input and pass and string argument 10, it returns 20. And if you pass process input and string argument ABC, it gives us the invalid input message. This is an example of how nested functions allow us to hide helper functions from the outside world, making our code cleaner and more secure. Now, why would you want to use such functions? Here are some key advantages. Encapsulation. As we saw, such functions allows us to keep helper functions private to their parent functions. Another is maintainability. If a function only makes sense within the context of another, Keeping them nested keeps your code cleaner and easier to understand. And the last one is access to outer variables. Nested functions have access to variables from their outside functions, which is handy when you need to keep state between function calls. However, like all things, such functions have their own limitations. First, because inner functions can't be accessed from outer. First, the inner functions can't be accessed from outside the parent function. They may limit reusability. Also, too many such functions can make your code harder to follow if not used carefully. So always try to find a balance. So there you have it, nested functions in Python. They might seem simple at first, but once you understand closure, encapsulation, and scope, you'll see how powerful they can be. Whether you're keeping your code clean, hiding functionality, or taking advantage of closures, nested functions are a tool every Python developer should master. Today, we're diving into the fascinating world of Python built-in modules. These are libraries that come pre-installed with Python and can save you tons of time and effort. Stick around because I'll not only introduce the concept but also show you some practical example to make this journey fun and engaging. So we'll get started by understanding what built-in modules are and why they are so powerful. Built-in modules are Python's way of giving you a toolbox packed with pre-written functions and classes to perform common tasks. They save you from reinventing the wheel. Examples include math, OS, datetime, and many more. You don't need to install them, just import and use them. With just a single import statement, you unlock a wealth of functionality. So we'll explore these examples one by one. First of all, we start with the math module. The math module is great for performing mathematical operations. We'll see this in action. Here's what we are doing. Math.sqrt16 gives the square root of 16. Math.py gives us the value of pi, handy for calculations involving circles. And math.factorial computes a factorial of a number. Similarly, we'll see this OS module which helps us to interact with the operating system. With os.getCwd shows you the current directory. os.listdir lists all files and folders in the directory. And os.makedir creates a new folder with the given name. The third one is the datetime function. It is very good for working with date and times. Here's what's happening. Datetime.datetime.now gives the current date and time. strftime lets you format the date in any way you like, and time delta days equal to 7 adds 7 days to the current date. Now it's your turn. Which modules would you like for the following task? Find the greatest common divisor of two numbers, check if a file exists, and calculate the difference between two sides. Pause the video and then comment the answer below. Here are the actual answers. Use math.gcd for greatest common divisor. Use os.path.exist to check if a file exists, and use datetime for date difference. And there you have it. Built-in modules in Python are incredibly powerful and easy to use. Today we explored just a few examples, but there's so much to discover.
Hello everyone and welcome to this video. In this video, we're going to discuss about a library called Pandas, which is a Python library and which is very important, especially if you're going data science, data analysis, machine learning, natural language processing, and many other applications in the field of artificial intelligence. So let's just begin. We'll name this Pandas tutorial. Okay, so first of all, we'll start with a series. So a Pandas series is a one-dimensional ND array with axis labels, including time series. We'll first see how to create our Pandas series here. So let's first use our NumPy array. Name create Pandas series. First of all, we'll see it using NumPy array. So import NumPy as np and import pandas as pd. Okay, so let's give our labels here. Labels equals to a, b, and C, and we'll have a list of some kind of values. So demo list equals to, let me write 10, 20 and 100. Now if I want to make this a series, first I'll convert this list to my NP array here. So this is demo underscore list, and I'll then create a series from this array demo. The data is array demo, and our index will be the labels that we find. Okay, so if we print this, we can see that we've created a series. If we want to check out type, this one, we'll first assign this to a variable. Okay, so pandas underscore series equals to something, and we'll run this, and we'll check what the if a generated variable is actually panda series. So yeah, it's a panda series here. We can also create this using a dictionary. So using a dictionary, what we can do is we can create a dictionary. That's demo equals to, and then we'll just give our random values here. So A, and its value will be 10, B, its value will be 20, and C, and its value will be 100. Okay, so now what I need to do is I can define pandas underscore series. Again, I'm keeping the same name so that we won't be creating many more variables here. So we'll try to keep it simple here. So pandas dot series, and then my data is going to be dictionary underscore demo. So if I print this pandas underscore series, again I see the same form that I had saw previously, and I print the type of this one, pandas underscore series. It should be a pandas series class. Okay, now what we can do is we can also use a list. So we've already seen how to create a series using array and using a Python dictionary. Now we'll also try to create it using a series, using a list. So let me just create this list here. I think this should be sufficient for me. So demo list equals to 10, 20 and 100, and what I'm going to do is pandas underscore series equals to pd dot series, and I'm just going to give my list here, demo list, as data. I can do data equals to demo list, or just write demo list here, it's fine. And if I print this pandas underscore series, what you'll notice is I won't have these labels here like I've defined in the previous two examples, but I'll have just the index, or I'll have default labels assigned by pandas here. Now let me also check the type of this one. So this is again, or should be again, a pandas series, which is correct. Okay, so what do you think is the main difference between a pandas series and a single column data frame? Okay, we'll come to that question later on. We'll first work out on the series first, go to the data frame, and then we'll see the difference of it. Okay, so the next part we're going to see is how can we convert a pandas series to a list. So we've already seen how we can create a pandas series using a list. Now if we have a pandas series, now how can we convert that to a list? So we'll see that. Let me write this: converting a pandas series to a list. Okay, so let me say, okay, I won't do import because I've already done import pandas as PD here, so I'll just leave it here. So let me write series demo equals to pd dot series. Okay, so I'll have maybe a few variables, 10, 11, 14, 15 and 16 for now. And now if I see the type of this one, it should be a series, which is right. Now if I have to convert it into a list, what I need to do is, let me name it demo list, and what I need to do is series demo dot toList function of our series. We just need to use toList function of our series, which will convert our variable type or our variable class to list, and then also print out the variable here. Okay, so print demo, type demo list and print demo. So our values has been converted from a series to list here, and you can also see the type, the class type of our new variable demo list here, which is a list. Okay, now after this we've already seen how we can convert a list into a pandas series. Now we're going to introduce a data frame here. So how can we convert a series to a data frame here? So converting a series to a data frame. So I'll just use my same series here called series demo. So these all have just 5 different values or 5 different rows. Now what I'm going to do is I'm going to print type of series demo first, and what I'm going to do is I'm going to convert my series demo into a data frame. So how can I do that? Just do series demo and then use a function, a series function, to underscore frame, and then your series will be converted into a data frame. So let me print my demo underscore df first, and after that let me also print the type of demo underscore df. There should be a data frame here. So as you can see, the first print statement shows that series underscore demo is a series, and after that whenever I printed demo underscore df, after converting it into data frame, my data frame seems like this. These are the index values that I have, 0 1 2 3 4, and then this is the default column value that my data frame has assigned, and we can also see that its class has been changed to data frame from series. Okay, now what I'm going to do is let's sort our panda series. Okay, so let's sorting our panda series. So how can we sort our panda series? Again, I'm going to use the same series that I've defined earlier, just five values. Now if I want to sort this in ascending order, let me write ascending order. So if I want to sort this in ascending order, what I need to do is print, I'm just going to print it here directly. So series underscore demo dot sort underscore values function, which is given by our series class itself, and then one parameter ascending equals to true. So if I print this, now my values has been arranged in ascending order. Well, my value was previously in ascending order, as you can see. So let's change this: 16 14 11 maybe 12 and maybe 15. Okay, 15. Now if we run this again, we can see that our values has been arranged in ascending order. Similarly, if you want to arrange it in descending order, what you can do is you can use the same function while only the parameter changes here. So you just need to write ascending equals to false. Well, the sort values function accepts ascending here, but it does not accept the other, that is descending parameter. So you'll need to use ascending equals to true or ascending equals to false here. Okay, so as you can see, the series has been sorted into ascending and descending order here. Okay, so now we'll again go back to our data frame here. So how can we create a data frame? So we've already seen how can we convert a series to a data frame, but let's create a data frame using our list first. Okay, so I've already imported pandas, so I won't do that. So what I'll do is I'll just create a list, maybe 10 15 12 and 9, and I will create a data frame from this one. So pd dot data frame, pd is my pandas library which I've imported here. Okay, so pd dot data frame, and I just want to give my list variable inside and then print it. So you can see that it's a data frame here. If you want to check the type of it again, so let me write df equals to pd.dataframe. Let me print the type of demo list first. Obviously it's a list, but still let's see. And then print our df and also print the type of df here. Type of df here. So as you can see, our demo list is a list. We've converted it into data frame, or we've created a new data frame from that list, and then the data frame looks like this. Again, 0, 1, 2 are index, 10, 12 and 9 are values, and then the first 0 that you see here is the default column name provided by the pandas data frame, since we have not assigned any column name in here. So yeah, this is it. And then when we check the type of df, it's again a data frame. We can not only use a one-dimensional list, but we can also use multi-dimensional list to do this, okay, to create a data frame. So using multi-dimensional list, what value should I add? Okay, I'm going to add some Arsenal Football Club's players name. So Gabriel Jesus, and then his squad number is 10. Again, another player, which is Martin Odegaard, and his squad number is 8. And another player, Gabriel Martinelli, whose squad number is 11. So if you are a big football fan or an Arsenal fan, you can easily relate to these data. Okay, so let me create a data frame from this one. So pd.dataframe. I just need to give my demo list here. Again, if you want to check the type of this one, you can simply print the type of demo list first. It's a two-dimensional list here. So okay, and then I'll print my df, and also okay, we will first print the type of df, and then after that we'll print df here. So as you can see, I had a list previously called a demo list, from which I created a new data frame called df, and then since I had multiple values in a single index of this outer list, so what it does is it inserts it into one particular row. So again, 0, 1, 2 are indexed, and 0 and 1 are the default column names generated by the data frame itself. Okay, so this is how you create a data frame using a multi-dimensional list. Well, you can also do it using a dictionary, which we are going to do here. So using dictionary, what you need to do is I'll just create a demo dictionary. Again, I'll use the same example here. So for this one, what you do is you first define your column name, and after that you define your values here. So maybe Jesus, Odegaard, and Martinelli, and after that one you again have a second column where you'll first assign your column name. I'll give it number, and after that you'll again create a list and then put the values, or here I've inserted the squad numbers here. So now again I'll do the same thing. I'll just copy this. Okay, so pd equals to df equals to pd.dataframe. I'll give a demo dict here. If I want to check the type of this, what I can do is print type demo underscore dict here, and then create a data frame using demo dict, and then print the type of the data frame, and then again print the entire data frame here. So you can see, as we had given our own column names or labels to the data frame, so instead of 0 and 1, the data frame consists of the column names or the labels provided by us, and the values are somewhat similar. Okay, so this is how you create a dictionary into your data frame. Okay, so now we move to another example. Let's say how can we add another column to an existing data frame. Okay, so we already know how we can create a data frame. Let me use this same data here. So we have name and number. if I print df here, we can see that we have name and number. Now if we want to add a new column to this one, what I need to do is I simply need to introduce a new column name here. So let me say this is my goals, since the season has already started. Again, if you're a football fan, you can kind of relate to this. So yeah, the season has already started, and then among these three players, Gabriel Jesus has scored 2 goals, Odegaard has scored none, and then Martinelli has scored 2 goals up until now. So if I add this one, what happens is now a new column has been added to an existing data frame here, which is called goals, and then their respective values. So this is how you add columns to a data frame. Now what we can do is you can also append one Panda data frame or one data frame to another data frame. So how do we do this? Suppose let's say I have a data frame with the same value. Let me call this df1. Let me remove this print statement, and then what I'm going to do is I'll add some more values here. So demo underscore dict1 equals to, again, I'll just copy these values and then create new data within them. So the name is going to be, again, more players. So the name is going to be Saka, and okay, who else is Zaka, and White. So here's Ben White, Granit Xhaka, and then Bukayo Saka. So their squad numbers are 7, 34, and 4. Okay, so now what I need to do is again, I'm going to create a new data frame here. So df1 and df2 are 2 separate data frames, as you can see. So now what I want to do is append one data frame to the other. So basically what I want to do is I want to append df2 to df1. So for that I just need to use append function of the data frame, and then what I can do is I can do df2. So df1 dot append df2, and if I print this, you can see that I have a combined value. Okay, so did I miss something? Sorry. So yeah, df2 should have dict2, and if I print this, so yeah, I have Jesus, Odegaard, Martinelli, and then from the second data frame, Saka, Zaka, and White. Again, we have the names and numbers as we had assigned, but one weird thing that you might see here is the index values that we have. So 0, 1, 2, the first three index are from the first data frame, and then the last 3 index are from the last data frame or the second data frame that we have, but these index are not arranged here. We'll do that, but we'll do that after some time here. Okay, before that, what I want to do is I want to sort my data frame based on the kit number that I have. Okay, kit number. Okay, okay, so based on the kit number, what I need to do for this one is, since I already have a data frame 1. Okay, sorry, so I haven't appended this. So what I need to do is df1 equal to df1 dot append df2. If I print df1, I already have this appended data frame. So now what I'm going to do is I'm going to sort this data frame based on my number here. So df1, again, use a function called sort values. What do you want to sort it based on? So by this is going to be sorted based on my number. And again, if you would like an ascending sort or descending sort, just give your values here. So I'll write ascending equals to true. So what should happen here is the order of players that we have should be sorted based on these numbers. So the first data should be White, second should be Xhaka, Odegaard, Jesus, Martinelli, and then Xhaka. We'll see if it happens or not. So as you can see, based on the kit numbers, the entire data frame is sorted here. Again, the index looks very random, but we'll work on that later on. We'll also try try the opposite of this one. So just ascending equals to false, which means we're going to sort this in another order. And as you see, the highest number is first one, and then the lowest kit number is on the last row here. Again, the indexes are all messed up. We'll organize that later on. So now if we have a data frame, how can we export this data frame to a CSV file? So for that, we already have a data frame called df1. Again, I'll print this out. So it's just in random order. So to export this data frame into a CSV file, what I just need to do is df1.to_CSV, which is again a function provided by your data frame, and then you just need to give a name here, just call arsenal.csv, and then we'll be done. Let's see. Okay, it's imported. We'll check if our if our data is actually imported or not. So copy link. Okay, so we have arsenal.csv here. If we want to open this, we can see a name, number. At first we have index 012, and then the names of the players, and then the kit numbers that we have. So we successfully exported our data frame to a CSV file. Okay, so after this, we'll work with our data frame indexes here. We'll try a simple example. We'll first let me just create take this value and then create a data frame out of this one. So we have df1 here has a single data frame. What I want to do is I just want to select one column here. So select only name column from here. So for that, what I need to do is, let me just write print, or I'll just write df1 and then just hit name here, and then you'll see that only the name pops up here. Again, if you want to print only the number here, again the number pops here. We'll do something different. We'll only select our second row here. Okay, we'll only select our second row here. So how can we do that? Just hit df1, and we'll use an ilog function here. So ilog, and then since we need a second index variable, so this is how we represent it, and then we'll print our second value, which is Odegaard, and then the kit number is 8 here. Also, what we can do is we can select the top two rows that we have. So for that one, again df1.ilog, the format is going to change here a little. So from 0, the maximum limit is 2, but sorry, the maximum index that we want to include is 2, but when we give 2, it takes one value lower than that. So if we print this, again we have just 2 rows. If we only want to print 1 rows here, so what we can do is, if we only want to print the top row here, hit 1, and then we have top row here. Or if you want to print all 3, hit 3, and then you can work out with this. Okay, so now what we want to do is, since we've already exported our data frame into a CSV, what we want to do is we also want to read a CSV and then convert it into our data frame here. So I'll just import my pandas once again. It's not actually important, but let me do this. So let me write data equals to pd.read CSV. You have this read CSV function, and then I have arsenal.csv file in my folder. So I'll just read that, and if I sorry, so I don't have arsenal.csv here. Sorry, my spelling was all wrong. So okay, I do have arsenal.csv, but what happened here? I do have arsenal, so it's arsnel.csv. Okay, so let me just copy the name from the directory and then paste it. Okay, so if I import this and then print my data here, so I have a new index added to this to this data frame, I also have my old index and then my player name and then my get number here. Okay, so the old index is being brought here as a new column here, which we can also remove based on our requirement something. Okay, so this is how basically you read a data frame. Well, sometimes you might get your encoding error for while reading a CSV file. So for that, you basically need to include your encoding format just as a parameter here, and then you'll be set. And if your file is since your file is comma separated, we don't need to mention our delimiter here. But if your file is tab separated or something like that, you also need to give your delimiter here. And then based on what maybe it could be a new line, maybe it could be a new tab, new space, or 4 space, 5 space, you can read your CSV file from here. Okay, so this is how you do it. Now after that, what I want to do is I want to perform some aggregations of this data. So to keep things simple, I'm really using this same data frame here. So let me create this data frame again. I won't use this data because it has this unwanted column which I should remove. I'll teach you how to remove that, but again we'll come back to it later on. And what I want to do is I also want to include goals here, goals of each players. So goals, and now my striker Gabriel Jesus has scored 2 goals this season, Odegaard 0, and then Martinelli has scored again 2 goals. So now what I want to do is if I print df1, again you have this data frame. Now I want to perform some aggregations, basically 3 aggregations. Okay, so the first aggregation is the minimum value. So what I want to do here is print out the minimum number of the lowest goal that has been scored by any player here. So number dot min will give you the lowest. Sorry, I want to do it based on goals. Okay, so which will give you the minimum value among these 3 values here. So again, if I want to print the maximum values, what I can do is, so goals dot max, it should give me 2 goals. We can also do the sum of these goals. Okay, so the total of 3 players have scored 4 goals. Sorry, not here. I scored a total of 4 goals here. Okay, so this is how you do basic aggregations. So I've just shown you min, max, and sum aggregation here. We can also do our group by aggregations here. Okay, so group by aggregations. So for that one, what I want to do is I want to use this same data, but I want to use I want to add some more rows to this one. So let me write Saka and Xhaka and Ben White here, and then the get numbers respectively are Saka has 7, Xhaka has 34, and then White has 4, and then they have also scored goals. So Saka has scored 1 goal, Xhaka has scored 1 goal, and then Benjamin White has scored 0 goal. What I want to do is I also want to add one more column to this one, which will be our position, which we'll keep using later on too. So my first value, Jesus, is a forward, Odegaard is a midfielder, Martinelli is a forward, Saka is again a forward, Xhaka is a midfielder, and my Ben White is defender. Okay, so I've added these. Now what I want to do is I want to create a data frame from this one. Again, I can use the same syntax. So I have name, number, goals, and position. Okay, so what I want to find out is, first of all, I want to find out the total number of goals scored by each position here. So if I want to know how many goals my forward, midfielder, and defender has scored in total, what I can do for that one is df1, and I'm basically comparing this with two positions. The first position will be, sorry, the first parameter will be my position. My second parameter will be goals. Let me just wrap this up into another list here. Goals, and what we'll do is I'll do group by. So what are we going to group this by? We're going to group this by position, and then hit sum here. So if I see my defender among these data has scored 0 goals, my forward has scored 5 goals. Is this correct? So Jesus is a forward 2 goals, Martinelli is a forward 1 goal, and Saka is a forward, sorry, Martinelli is a forward 2 goal, and Saka is a forward 1 goal, which is 5 goals. And my midfielder Xhaka has scored only 1 goal. So yeah, you can also do this group by aggregations based on your data. Again, if I want to see the maximum of every position that I have, I can simply do this. So my defender has scored a max of 0 goals, forward has scored a max of 2 goals, and then the midfielder has scored a max of 1 goals here. And then I can also do a minimum. Again, the minimum will be the same because both of my, I'll just enter this and see. Again, my defender has scored a minimum of 0. My forward has scored a minimum of 1 goals because each and every forward has a goal. The player Bukayo Saka has the lowest, which is only 1 goal. And my midfielders, there are 2 midfielders. One has scored 1, and then the other has not scored. So it should be 0 goal here. So this is how you do group by aggregations too. Okay, and then you can also combine. You can also apply group by aggregations, or like you can also apply group by with 2 different aggregations here. So I'll just show you how you do that. Apply group by with 2 different aggregations. So for this one, what we can do is, so df1 dot group by, you'll want to group this based on your position, and then what you want to aggregate is you want to aggregate your goals, and basically you want to add, okay, now these parameters can be anything, but I've added a mean, a sum, and a median here. Okay, np dot median. So if I print this, so my defender has a mean of 0 goals. They have no goals at all. They have sum of 0 goals, and then the median of 0 goal. My forward has a mean of 1.67 goals, a total sum of 5 goals, and then the median of 2 goals. My midfielder has a mean of 0.5 goals, the sum of 1 goals, and then the median of 0.5 goals. Okay, so this is how you can apply group by with multiple aggregations here. You can add as many aggregations as you want after this too. Okay, so now what we want to do is we want to find out our missing values in our data frame. So finding out missing values in data frame. For this one, I'll use my same data frame here that I had created earlier, but I'll change a few values so that we can find our missing values. So suppose we say our player Granit Xhaka has no kit number, or the kit number value is actually missing, and then our player Ben White has no position, let's say. Okay, so Ben White, or like maybe we can say Martin Odegaard has no position here. It can be none. Okay, so now if we create a data frame here and then print this out, what we'll see is we'll see a data frame, but there are null values here. So this is an n, and then we have a null value here. So let me check how many null values are actually in this data frame. Since it's a small data frame, so we can basically say there are two different columns that has null values here. But in case of a very large data frame, going through it manually is a tedious work, so we can just use this isNA function and then do the sum of it, and then we can see so that there are 0 null values in name, 1 null values in number, which is this one. Again, 0 null values in goals, and then 1 null values in position. So now, how can we remove these null values? Okay, so we'll work on removing null values from here. So for that one, what I can simply do is df1 dot drop na, and then I'll do in place equals to true, which actually does not mess up our index here. And basically, if I print this out, so okay, sorry, I also need to print this out. So if I print this out, what will I see? Okay, so it's done. Okay, so this is an aggregate function, and then if I print df1, now we see that there are no rows with null value. So basically, one row with null value, the row number 1 is removed, and then the other row, which is row number 4, or like index number 4 is also removed, and then we only have 4 rows out of 6 rows. So yeah, this is how you can remove your rows containing null values in any column from the data frame. We can also find out, so like whenever you're working with a very large data set, we can also point out the exact index or the exact row number where you have your null values there. Okay, so let me just redo this again. Let me just use the same thing again. So I have this data frame with null values. So what I can do is I can iterate over my data frame to find my null values. So for that one, for index and data in df1, so now if pd dot is na, and okay, what do I want to find my null value based on? So I'll just use data here. Okay, nothing else, just a single row here, nothing else. And what I want to do is I want to print my position or my row number, which has null values, and then this row number is going to be my index, and I'll also print my data here, where my row value actually occurs. So data here, and let me just write data and my, okay, what do we want to paste? Okay, so I want to basically find null values based on my number column. So if I do name here, what I can find out is, okay, so I missed something here. Sorry, comma, there's no comma. Okay. Print row number and my index, comma, and my data equals to, and my data name. So this should be correct. Oh, sorry. So okay, df1 dot iter rows. So I want to iterate over the rows of my data frame, and I can see that based on my number, my row number 4, Granit Xhaka, has a null value here. If I just want to base this on nothing here, we'll see what happens. Okay, so we should give some value here, or some column name here. Okay, so based on that only we can do this, or we cannot pass our entire data frame here, but we actually need to pass our series here. Series means just one column here. Okay, so we can also do this based on our position. So if we see row number 1 Odegaard has a null value. Okay, so moving on, what we want to do is we want to reindex our data frame. Reindexing basically means the weird index that we had seen earlier. Let me go back to that position again where we had that. Okay, so yeah, we had this here. Let me just copy these statements, and then we'll see how our indexing is all messed up. So let me print df1. I have df1 with 3 players, df2 with 3 players, and then I've appended my df1 with df2 and then printed it. So yeah, it has all kind of weird index here. So for that one, what I need to do is what I want to do is I want to have an index. So basically I want to give my own index 1 2 3 4 5. I have 6 players, so 6 players. And what I want to do is let me just use my reindexing function. So df1 dot reindex, and then I want to give my new index values here. And then if I print my okay, what happened here? I cannot reindex on an axis with duplicate labels. Oh, okay. So I first want to arrange this, and then I want to use it. Okay, so what I'm going to do is I'm just going to use reindex here for now. So 1 2 3. Let's not use reindex, but let's create a data frame based on the demo date1, and then I want to provide my own index instead of the index provided by the data frame itself. So index equals to index. If I print df1, I can see 1 2 3 index, and my index doesn't start from 0, but now it starts with 1. Now what reindexing actually means is I want to shuffle down the row number based on my interest. So let me say index equals to, I'll first show my second row data first, and then first row data, and then third row data. What I can do is df1 dot reindex. If I hit index, what it does is it reindexes my data, or like shuffles my data based on the order that I have provided. We can also go back and then do the thing that we are trying to do, basically reset our index and then have a standard 0 1 2 3 4 5 6 here. So for that one, I'm going to copy this. Basically I want to reset my index here, so reset my index. And okay, if I print df1, I have these all kind of weird indexes here. So without appending, what I want to do is I basically, okay, so if I append, I have that problem. But if I don't append and use a concat function, so final df equals to pt.concat, I can also concatenate data frames using my concat function instead of using my append function. So df1 df2, and if I give ignore index equals to true, now if I print my final df, you'll see that my indexes are all arranged, which was not the case when I used my append function here. Okay, so this is how you reset your index using concatenation function, and then you can also do the same after sorting your values. So I just do okay, so df1 dot sort, so df1 equals to df1 dot sort underscore values. So I'm going to sort this based on my numbers here, numbers here. Okay, number here, and then I'll say ascending equals to true. And if I print this, you'll see that my index is again messed up. So yeah, if I want to reset this, what I can do is df1 equal to df1 dot reset underscore index, and then drop equals to true. So if I print df1 now, you'll see that the rows are not changed, but my index has been reset, and then it has been regenerated here. Okay, so yeah, this is how you reset your index. Now one interesting thing I'm going to show you is perform binning on categorical values. So let's say you have a range of data, or like a particular set of data, maybe 5 columns, or maybe 5 distinct categories of data, or 6 distinct category of data, and then you basically want to group them based on their maybe their order or something like that. We'll basically try to group here based on our players position, so how high they play or how low they play or how like in the medium they play. So I have this data frame that consists of, let me just write demo underscore df1. So I have this data frame that consists of my players, 6 players, and then their positions here. So now what I'm going to do is if my players are playing forward position, I'm going to basically add a new variable or add a new column and then adjust their values maybe like they're playing higher. If they are in midfield, they're playing medium, and if they're in defense, they're playing low. Or also I can arrange it based on the goals they have scored. If they have scored maybe top goals, maybe 4 goals or 5 goals, I'll say like they have higher number of goals. If they've scored lowest goals, they have low goals, and then if they are in the middle, they have scored medium goals. So how do we do that? Let's see. Demo underscore df1. I'll say goals underscore bin, since I'm doing binning here. And for that one, I need to use a cut function, pt.cut function, and my data frame demo underscore df1. And I'm doing this based on goals. I want to basically categorize them into 3 different categories, from low, medium, and high, and then I'll give my own labels here. So these labels can be low, medium, and high. And now if I print my demo underscore df1, what I can labels equals to low, medium, and high. And now if I print, so my player who has scored 4 goals has been categorized to high. My player who has scored 3 goals has been categorized to high. 2 goals is medium, 1 goal is low, and then 1 goal is low, and then 1 goal is low again. So if I want to do this maybe just into 2 distinct categories, low and high, I can also use this. And then if we see 4 and 3 categorized as low, and then anything lower than 2 is categorized to 4 and 3 are categorized to high, and then anything lower than that are categorized to low. So such kind of transformation can be very important, especially if you're doing data analysis. If you want to categorize your continuous data that you have based on certain categories that you want to put in. So yeah, you can basically perform your binning here. So after this, what I want to do is I want to find out which of my columns are actually my categorical columns, and then which of my columns are my numerical columns. Okay, so how do we do that? Especially I'll do it for the numerical column. So what I can do is I can say all columns equals to list, and then demo underscore df1 dot columns. If I just print this, I'll get my all columns name, LUMNS. Okay, so I'll get my all columns name, and then from this one I can separate numerical columns based on a very simple function. Numerical columns equals to list demo underscore df1 dot underscore get underscore numeric underscore data, and then I can and then I can just write dot columns columns, and then if I print my numerical columns, you can see that my numerical columns are just numbers and goals here. The rest of it are all categorical. Maybe they have text in them, or maybe they have string categorical values in them. So this is how you find out which of your columns are numerical, and then which of your columns are categorical. What we can do is we can also assign we can also convert our categorical data to numeric data. So for that we are going to use a function called cat.codes. So how do we do this? Okay, we already have our demo underscore df1 here. So we have okay, we'll take this position here and then convert it into our numerical value. So this is basically a categorical value. We'll convert this into a numerical value. Now how we can do this is let me say demo underscore df1 position position equals to demo underscore df1 position dot as type, and then this will be a category type. So this is a category value that I have here, and after this I want to convert this into numerical value. Maybe I'll add my new column here, postcodes equals to demo underscore df1 position dot cat dot codes. Then if I print my demo underscore df1, what happens is I have a new column here which is a position code, and then I've converted my defense to a 0 numeric value, midfielder to forward to 1 numeric value, and then midfielder to 2 numeric values here. Okay, and so yeah, this is how you convert your categorical data into a numerical data. So okay, we've done a lot of things in pandas here, so I think you understand this. If you have any problems, or like if you face any problems, please let me know in the comment section. I'll try to help you out and go through this. It'll be very important if you're especially starting to go inside data science, or like if you are practicing data science and then don't have a very good grasp on pandas. Well, I hope the tutorial can be very useful to you. Okay, so yeah, only this much for today.
In this video, we're going to learn about NumPy and its basic operation in Python. So let's first start with importing NumPy. Import NumPy as np. Let's run this. First of all, we'll see a NumPy array creation, and we'll see it from a list. So let's say we have a list with values 1, 2, 3, and 4. We can easily create a NumPy array using this particular list from the function np.array, and then provide the list name. If you print this out, you'll see that this is of type list. If you want to confirm whether the type is correct or not, you can check the type of list1, and then you can check the type of array1. So list1 is of type list, while array1 is of type nd array. We can also directly create a NumPy array using this particular function, and then providing a list inside this. This is also equivalent to what we did earlier. So if we print this array, then we see that our NumPy array has been printed. Also, if you would like to check the type, we can do it, and hence our NumPy array is created. Next, we're going to create NumPy arrays using np.zeros. So create an array using np.zeros, and then provide a number. If you print this array, you'll see that a NumPy array has been created with 0 values, and the count of the values inside this array is the value that we provided inside this zeros function. We can also create NumPy arrays using np.arrange. So create an array using np.arrange 5, and then if you
print this, you'll see that we have a NumPy array. We have a NumPy array with value 0, 1, 2, 3, 4 because 5 is the ending condition and it's not included. You can also create an array with values starting from a certain value, ending in certain value with a certain step. So let's say we create an array from value 1 to 9 with step of 2. So array equal to np.arrange 1 comma 10 comma 2, because 10 will not be included, and then 2 is the step counter, 1 is the beginning condition. If you print this array, you'll see that we have a NumPy array with the values 1, 3, 5, 7 and 9, because we want to end our array along with this value 9 here. We can also create NumPy arrays using np.random.rand function. So for an array, np.random.rand, what this does is it randomly assigns a specific value for the array here. Also, we need to provide the dimension of our array here. So if we say 5, we get 5 different randomized value in our array, and the value will always range from 0 to 1 in this case. Now let's move on to creating an empty array. But remember that you should always specify the length of the array, even if you want to create an empty one. So for this one, we don't need to use np.zeros. We also have another function called np.empty, then provide the length. If we print this out, then we see that our array has been created with the length that we've provided and its value is empty. We can also create a multi-dimensional array from list of list. Say we have a list with value or multi-dimensional list 2, 3, 4 and then 5, 6, 7 and 8. Now if we convert this to array equal to np.array lists, then we see that we have now created a multi-dimensional array from the list itself. So this is actually a 2D array in our case. Your task is to create a 3D array using the same. So pause the video, write a solution and then replay the video to check if your solution is correct or not. So what we can directly do is I can directly write np.array and then provide a multi-dimensional list 3, 1, 2, 3, 4, 5, 6, 7, 8 and then 2, 3, 4, 5, 6, 7, 8. Okay, we'll add one more value. 7, 8. So what happened here? We have a total of 3 brackets. 2 brackets are closed here, then we have 3 brackets and then 3 brackets are closed here. So if we print this, then we can see that we have now successfully created a 3-dimensional array in our case. We can also create any dimensional array or multiple dimensional array using np.zeros like we did earlier. Say we want to create a two-dimensional array, 2D array with 2 rows and 3 columns filled with zeros. Then what we'll do is array equal to np.zeros 2, 3, where 2 will represent the number of rows and 3 will represent the number of columns. Now if you print this, you'll see a two-dimensional array using the same. Also, if you want to create a three-dimensional array using np.zeros containing the size 2 into 3 into 4, then we can do this using the same approach, np.zeros 2, 3, 4. And if you print this, you will see that we've successfully constructed a three-dimensional empty array here. If you want to create such arrays with a specific value, you can do array equal to np.full, provide the size that you want, let's say 2, 3. I'm just going to create a two-dimensional array with the value 10 in each case. Then you'll see that our two-dimensional array of 2 rows and 3 columns have been created with a specific value 10. You can use this full function here, np.full function here. You can also create multi-dimensional array, n-dimensional array using np.random.rand. So in order to do this, you can just write np.random.rand and then provide your dimensions here. So let's say two rows and 3 columns. If I print this, I see my two-dimensional array has been created. Again, the property of np.random.rand will be the same as I talked about earlier. So now your task is to create a three-dimensional array using the same. So pause the video, write your solution, and then play the video back to check my solution here. So array np.random.rand, and if I want to pass in 3 dimensions here, let's say 2 rows, 3 columns, and then 4, like 2 into 3 into 4, I can just do this and then print my array here. If I want to create n-dimensional array using np.empty, I can do the same. So first we'll create a two-dimensional array using np.empty and then provide our dimensions here. So 2 rows and 3 columns. If I print my array, I can see that my empty array has been created. So I still see that there are some values. In this particular case, Python is actually unable to create values with exactly 0 value. So there will always be something, always be a smaller or a smallest value associated with this empty function. So this is all for this video.